All right. Hey, for you, we're not here on Friday or today. This is how you get into the practice test for the STAAR. Go to 429 module on Canvas. Click on the link right here and scroll down to the bottom. It's just going to say practice test login. Hit that. And when you get here, don't mess with the guest user and guest session. Just click on sign in. Grade level, oops, come on. It's gonna be 9. And then you're here. Click on the STAAR 21 STAAR Algebra 1 new items type, that one. Okay, here you can mess around with the different features. You know, the color setting, large mouse. I mean, that's up to you if you want to mess with that stuff. Just just hit select, and then begin test now. You can view if you want to play around with the view test settings and all the good stuff. You can. All right. Okay, and then so the first question pops up, an expression. It wants you to solve. This is an exponential. Okay. So what I'm going to do right now, I can't write on this board right here, this window. So I'm going to go back and forth between the smart slides and this. And so you ask to simplify the expression. So let me go to my smart and okay, and go back one. So how do you do that? I'm going to write a little bit bigger. So I'm going to have x to the 6 over x y over y square and z to the 7 over z square. All right, remember when we divide with exponents, what do? We subtract exponents, okay? And so there's a 1 right here. And so for the x now, we're gonna get x, 6 minus 1 is 5. For the y's, it's the 1 right here. It'd be 1 minus 2, which is -1, and for the z, it's just 5. Now remember, we have to make our exponent positive, right? So that's a -1. So how do we make it positive? Well, we're gonna move to the bottom, and so this becomes x to the 5th, z to the 5th over y to the 1. It becomes positive. All right, now we're gonna put this in our answer. Let's see. All right, so how do we enter this in the STAAR login? Okay, here we go. This thing is just, okay, so it's a fraction, right? So I'm gonna hit the fraction button right here. Hit that fraction button. And so now on the top, I'm gonna enter, let's see, let me scroll a little bit. I'm gonna enter, where's my x? Oh, here we go, x. And the exponent is 5, right? So I'm going to hit this button right here, and that can give me put the exponent 5, and it's z to the 5 again. So now, if you notice now, right, the cursor is next to the 5. You got to be careful now. So you just tap next to it, or maybe not tap next. I lost it. Let me use the down arrow key because if I put a z there, it's going to give me this. Let's see. You see the z is next to the 5. That's not what you want. So let's back up for a second. And where's my delete key? And so where's my down? So that's why I got to play around with this thing. I want to cursor down a little bit more. Oh, there you go. All right. And so now we have z to the, where did my z go? Okay, z, and then the exponent. I'm gonna press this again. All right, press this one. Okay, I'm trying to mess around, okay, is 5. And then we have y in the bottom. Put the y there. And my y. Sorry. All right, guys, so let's make sure you play around with it so you become familiar with it before the STAAR test, all right? And then I press, well, that's my answer. I go to the next one. All right. Number 2 is you give them the function a quadratic function and they wanted it in standard form. So you got to remember now, what is standard form? If you're not sure, you're like, what is standard form? Remember, they have this reference sheet right here. Okay, just click on the reference sheet. And here is the references. That's factoring. That's not what I want. Let's go to quadratic and see what it tells me. If you don't remember what is standard form, that's linear equation. Quadratic standard form is ax squared plus bx plus c. All right, and so let me go back to, let me close that now. So I need to transform this equation to ax squared plus bx plus c. Let's go back to the smart slide. So I'm going to do that. Here we go. Now, how do we do this? Now we have an x plus 4 square. I've got to expand that. And to do that, x plus 4 square is just x plus 4 times x plus 4. And if you remember, guys, how do we multiply that? Right, the box method. All right. So we're going to use a box method to multiply that. Right, the x goes there, 4 goes there, x goes there, and 4 goes there. We'll multiply, that gives me x squared. X times 4 is 4x. 4 times x is 4x, and 4 times 4 is 16. All right, so I see some of you guys adding 4 plus 4 gives you 8 right here. No, no, no. It's 4 times 4. You got to multiply, and that gives you 16. So when I come by my like terms now, it gives me my first term, x squared. My last term is going to be 16. And when you add these two, it gives you 8x. I see some person putting square there. No, no, you can't do that. All right, you're going to add 4 times 4 is 8. Remember now, we're not done because the minus 18 here. Minus 18. And then we combine like terms. That gives me x squared plus 8x. 16 minus 18 is minus 2. So that's my answer right here. In standard form. Let's go back to the test. So we have x squared. Let me scoot on a little bit. X, again, I'm going to use the power. 2. And then x squared plus 8x plus 8 x. And it's what, minus 2? Yes, I think it's minus 2. That's it right here. So now that's in standard form. That's what I'm looking for. All right. All right, next one. All right, on this one, I see somebody like today, some of you guys are struggling with this. Remember, I said in class, if you have an equation with one variable, how do you solve that? If you don't know to distribute, right, just use menu 3-1. Menu 3-1 will solve for m. So let's go to my slide. I'm going to do it both ways. Okay, here we go. Okay. Now we can, how do you solve this algebraically? You distribute, right? 6 times 4, 6 times negative 3. That's going to give me 24m minus 18, right? Plus 6 is equal to 4 times 4 is 16m plus 44. Okay, I want my m on the left side, so I'm going to minus 16 here, minus 16 there. So that gives me now 8m, right? And these two, minus 18 plus 6 is minus 12. Minus 12 is equal to 44. And then I'm going to add 12 on both sides. And so I'm running a space. Where's my scroll button? Oh, here we go. Okay. And that gives me now 8m is equal to 56. Therefore, m is equal to 7. Right? But if you're still struggling with that, guys, remember you can use menu 3-1 on your calculator, and it will give you m. Just remember, it's n solve. All right, you're gonna put that in the calculator, and but remember at the end, at the last parentheses, you got to put comma m there. Just remember that. Okay, next one. Let's go to the next one on the test. Oh, I can put my answer in. 7 is my answer. 7. All right, that's it. Let's move on. All right, here it asks you for, what is it asking for? Rate of change, rate of change, rate of change, right? Asking for rate of change. So remember, rate of change is just your slope. The slope. And so if you go back to the slides, slides, rate of change is just slopes. Just pick two, the delta y or delta x. Look, remember, the slope is formula is m is equal to y2 minus y1 over x2 minus x1. Which one's going to be your y values? Well, dollars is going to be your y values because dollars depends on how many carpets you purchase, each carpet. All right. So dollars is a dependent variable, x is independent. And just pick two values. All right, 980 minus, it's going to be 980 minus 840 over, all right, 140 minus 120. What does that give you? Well, that gives you 0, 4, 140 over 20, and that just equal to 7. 7. So go back to the practice test now. My answer is going to be, I'll put 7 there. 7, 7, 7. There you go. Let's move on to the next one. Now, this is the one that I don't know how to get you guys to understand the different functions. And if you're not sure, right, it asks for a graph. Again, use a reference sheet. Let's go to my reference sheet now. It's gonna be, we haven't talked about absolute value, so we can skip that. Oops, I didn't mean to do that. Oh man, oh man, oh man. Okay, okay, it's not absolute value. I hit it by mistake. All right, so is it linear? Well, go back to your reference chart. All right, and so you can use this as a guide to help you with a different function. You know it's not linear because linear is just y equals mx plus b. All right. It's not quadratic because, yeah, but this quadratic, the quadratic has a power of 2. So that's not quadratic. So it has to be, and do we have exponential there? We don't even have exponential there. All right. So if it's not linear and it's not quadratic, then it has to be exponential. All right. So let me see if it will, there you go, exponential. All right. Okay, so one way you can do this, right? If you're not sure what to do, you can graph this in a calculator. Graph it in a calculator and see what it looks like, and then adjust the graph, okay? So the key thing to remember now is 6 is your y-intercept, and if you notice, the factor is 2 over 3. That means that the graph is decreasing, right? The factor is 2 over 3. So this graph is increasing. So I need to make it decreasing. And to move it, just click one dot and drag it. Now it's decreasing. Well, look at it now. The line crosses at 1. All right, that's not where it needs to be. It needs to go, it needs to cross the y-axis at 6. So I'm going to drag this up now. It needs to go up to 6. So I'll make this one cross 6 right there. So these 2 points have to be correctly. Has to be placed correctly. The first one is good because it crossed the line at 6. So where do I put a second dot? And that's where, if you can graph this function and do Control T, you can see where the x and y values are. I'm going to use Desmos to graph this because I'm not try. Let me try the TI. I've not tried this one, the TI graphing calculator here. It looks confusing to me. It's supposed to be similar to the ones that you guys use in class, but let's see, graph. Okay. Where do I put my graph in there? Tab, is that tab button? No. It's a little bit different. So I'm not gonna mess around with this TI right here. I'm not sure how to use it. I don't see, let me see if I put in Y. let me see something. Where's y at? Not going to use this, guys. All right, so you can use the calculator on the test, the yellow one. I'm not going to use that one. I'm just going to use Desmos. All right, and so I'm going to graph a function. Okay, I lost my. It's y equals to. It is y. Where's my y is equal to, I believe it was 6 parentheses, right? 2 divided by 3, and then parentheses, close parentheses. I think it was exponent, right? Now for exponent, right, I just use the AB because that's what I want exponent to be x. And that's x right here. See, now I have my graph, but I notice now, right? The line crosses at 6, which is matches right there. Now I got to find a second dot. All right, and so where am I going to put that second dot? Well, you can look at a graph and you can estimate it, or you can go to tables. Desmos, I like Desmos. Click on the little wheel right here. Click on it, and it gives you, and then click on table, right? It gives you all the x and y values for the graph. So there's a sprocket wheel, and you can see that, right? When x is 1 here, right? Y is, oops. When x is 1, y is 4. So if I move this dot now, which is, look at that, it's right there. So it's in the right location. When x is 1, y is 4. And that's it. If this second dot is not in the right place, they're not going to give you full credit. Good. Whoa, so that was that one. Let's see, let's go back to the test. And how do I need to close this thing. Let's go to, oops, that's not what I'm looking for. Oh man, what did I do? Sorry, guys. Zoom, cancel, don't want to do that. Okay, I need to close this thing out. What I can't see is, I'm trying to close out the Desmos graph, but I can't see the X button to do that. It's not getting me there. It's not getting me there. Oh my gosh. Okay, close that out. That's not. Okay, let me pause this and I come back and clear this up. It's taking too long to do that. Let me pause this. Okay, so yeah, so we're back to number 6 now. So look at number 6. You got to figure out again if it's a quadratic, exponential, or linear. And again, once you see x squared, once you see x squared in your graph, right? Okay, let me go back to the slides real quick. Okay, once you see x squared in your graph, that tells you it is an exponential. So now, so the graph's exponential. So let me. I'm sorry, not exponential. It's quadratic. It's quadratic, and so that's quadratic right there. So this what's going on here is transformation, right? It's transformed to minus, and I can't get it's minus f of x minus 3. So the minus sign tells you that the graph is flipped. So if you flip this graph, now again, just put your finger on one of the points and move it up. All right. Now you flip the graph. The x minus 3 now tells you that the graph shifts to the right 3 units. So now I'm going to shift it 3 units to the right. And it's going to play with it a little bit. Okay. So this is 1, 2. Makes this more, and 3. Now I'm moving 3 units to the right. The plus 4 tells me that the graph went up 4 units on the y-axis. So that is 4 right there. 4 units. So this second point now, we're gonna figure out, is it in the right place? If it's not in the right place, I'm gonna give you, it's not correct. And so how do you figure that out? Well, let's go back and look at this transformation here. This one, yes. And so again, the parent graph is f of x is equal to, let's put b on here. 200, that's why. My f of x is equal to x squared, right? It's transformed to x minus 3 plus 4. So what I'm going to do now with x minus 3 inside of parentheses plus 4. That's my f of x right there. So that's the graph when it's transformed. And so you can grab this in your calculator. I'm going to use this minus. I'm sorry, this is minus equals 1. I'm going to graph this in my calculator in my TI. I'm not going to use this because I'm already messing it up. And so home new graph, and if I remember correctly, it is minus parentheses x minus 3 close parentheses. Something's wrong here. What am I doing here? 20 parentheses minus, right? Open parentheses x minus 3. Good. Close parentheses, and then that's square 2, and then it's plus 4. Okay, so that's the graph now. I want to graph this. So that's what the graph looks at. So I got to figure out where I'm going to put that second point on that graph. But I want to see all the x, y values. Remember Control T? Control T tells me all the values. There we go. And so when x is 5, look at this. When x is 5, what is the y value? 0. So I can put the second point, point at 5, 0. So I'm going to do that. Could I use 4, 3? Yeah, I can use 4, 3 too. But I'm going to do that 5, 0. Let's go back to this. So this second dot, right, at 5 is at 5, 0. Right, I could put at 4, 3. Remember 4, 3 was 1 point right there. Or I could use 5, 0. It's up to you, but just make sure it's in the right place. And that's how you do that. All right, let's move on. Here, you give 3 points shown on a graph, and then want to graph the line of symmetry. Again, line of symmetry, it should tell you, you talk about quadratic functions. And so let's look at this now. Line of symmetry. Okay, so the line of symmetry, remember, it's going to split the graph in half. So if these 2 points are on my quadratic, on my graph, on my parabola, if these 2 points are right there, one is at 0 and the other one is at negative 4. So the line of symmetry is going to be a line that splits the graph in half. Right there. Okay. And so the graph, you can look at the graphs like this, something like that. So let's go back to this one now. So all I'm going to do is I'm going to put 2 points, one there, and you can put on top. Doesn't matter as long as I put 2 points directly above the x minus 2. That's where the line is going to cut the graph in half. X minus 2. X equals -2, I should say. X minus 2. Okay. X equals -2 is where the line going to split the graph in half. Okay. All right, next one. Okay, here you actually graph the equation. So remember now, when we graph the equation in the calculator, it has been formatted y equals mx plus b. So we have to go back out now and convert this equation. We're going to convert the equation to y equals mx plus b. I'm going to do that. Y equals mx plus b. So let's do that. And so we have 3x minus 5y is equal to 15. All right, so I could minus 3x and minus 3. I'm going to minus 3x on both sides. So that's going to give me now minus 5y is equal to minus 3x plus 15, and divide by -5. On both sides, -5, -5, -5, -5. Let's pull on there. That goes away. I'm looking at y is equal to 3 over 5x minus 3. Now you see my y-intercept is -3, right? And my slope is 2 over 5. Rise and run. So when we graph linear graphs, right, we want to use a rise and run. I'm going to start at -3. Let's go back to graph. So now I'm going to start at -3, right? So that's my starting point right there. And my slope is 3 over 5. Am I correct in saying that? Yeah. My slope is 3 over 5. That means I'm going to go up 3. It means that my slope now, I'm going to go up 3 and to the right 5. Up 3 and to the right 5. Let's do that. So I'm going to go 3. 1, 2, 3 puts me right at origin, and over 5, put me right there. And that's my line. All right. Yep. Let's take number 9. This is a good one too. Again, same thing, right? It's testing your knowledge of plotting graphs using rise and run. The first graph is the y-intercept score. The first graph, the y-intercept score, right? It got cut off. Oops. When I said it got cut off. So the first graph, let me go back here and look at it. It is minus 3 4 x plus 4 minus 3 4 x plus 4 minus 4. So it's minus 3 over 4x plus 4. So that's my first graph. And is it greater than? I think it's greater than. I think it's greater than. I don't want to go back and look. Oops. It is, yeah, it's greater than. Okay, it's greater than. So let's go back and look at this now. All right. So again, my starting point, right, is going to be 4 on the y-axis. Now, -3 over 4. This means that I'm going down 3 and to the right 4. So let's look at that now. So I'm going on 3. Let's go at the graph. Okay. So the first one, you got to select it. Again, it's because it's greater than. It's going to be a dashed line. So I'm going to start at 4. All right, the first one is 4, right? Start at 4. And then I'm going on 3 and to the right. So down 3, 1, 2, 3. So put that 1 and over to the right, 4, which puts me right there. The second one now is, look at it now, the second graph equation. My start point is -5 on the y-axis, and for the slope now is 3 over 2, up 3 to the right 2. So we'll start at -5. That's select first, select it. It's going to be a dashed line. I'm going to start at -5 and up 3. Is that what I said? Up 3? I can't remember. Yeah, up 3 to the right 2. So up 3 is going to put me 1, 2, 3. We're going to make 2 and to the right 2. See there? And so now the solution set. Go back and look at this. So if we look at this graph now, let me erase this for a second, all right? So we have a graph that looks something like this. Let me go back. Okay, if I remember correctly, guys, I think one went like this. All right. And the other one went like, am I correct? Yeah. Something like, I'm just going to guess it right. I hear dot, the dash line, dash line, dash line, dash, 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 dash. There, dash line. Okay. And so for the first one, we know the shaded area is above the line. Okay, and for the blue line, it's below the line. The shading area is below the line. Okay, so as you can see now, right, where they intersect right here, that's going to be my solution set. So let's go back now. See now that's so my solution set now is just going to be right here. So, all right, let's move on. Okay, what is the solution set for the equation here? Again, remember, all right, if you look at the inequality, it's less than or equal to, right? So you know I'm going to have a solid line. That's good. But remember now, again, write the equation in y equals mx plus b format. And the slope and set format, so I'm going to do that. Okay. This is what I did earlier. So the equation is 5x plus 6y is less than 30. Again, when we graph these, right, we want you to graph it and show the solution, all right, and show the solution set. You got to put it in slope and set form into y equals mx plus b format. So I'm going to minus 5x here, minus 5x on there, and that gives me now, that becomes 0, 6y is less than or equal to minus 5x plus 30, and divide both sides by 6. All right, divide by 6, divide by 6, divide by 6. And so I'm left with now y is less than or equal to minus 5 over 6x plus 5. And so I'm going to start at 5. 5 is my starting point on the axis. So let's see. So I'm going to start at 5. Right, and it's negative 5 over 6 again. It's negative 5. It's right. Negative 5 over 6. Therefore, I'm going to 5, right, and over 6. So down 5 is going to put me at origin, and over 6 is going to put me right there. And the solution set now, because it's less than or equal to, right? It's less than or equal to, it's going to be below the line. So it's, right? It's going to be everything below the line, which is going to be there. Good. All right, let's move on to this one again. Let's go, guys. You see number line. Don't, yeah, I like it. Like, whoa, number line. All right, just solve the problem first. Let's solve this first. All right. It just wants you to solve the inequality and then show the answer on the number line. That's all they're asking for. And so let's go back to let's solve this. All right. So we have minus 3, 2j minus 11 greater than or equal to 8j minus 9. All right, very simple equation. Remember, we're going to distribute. All right? Distribute. And so I'm going to have minus 6j, right, minus 6j plus 33 is greater than or equal to 8j minus 9. And so I'm going to minus 8j on both sides, minus 8j on both sides. And so this gives me now minus 14j plus 33 is greater than or equal to minus 9. And let's scroll down. I'm going to minus 33 on both sides now, minus 33 on both sides. So that gives me minus 14j greater than or equal to, we add those two, that gives you negative 42. Now, this is where you have to be careful now, guys. Okay. It's not sure my other bar where I can get more. Okay. So now we're going to divide by negative 14, right? I need more space. So I'm going to divide by negative 14 on both sides. Negative 14, negative 14. This we got to be careful now. Because you're dividing by a negative number, the sign's going to flip. All right, so that gives me now j. All right, it's going to flip now less than or equal. It's going to flip less than or equal to And that is just 3 4 is 12. J is less than or equal to 3. Negative 14 here. I'm sorry, it's negative 14. So J now is less than or equal to 3. So remember now, it's a less than or equal to, so it's going to be a closed circle. All right. So before I go to the number line now, remember real quick, if it's less than or greater than, it's an open circle. Less than or equal to, greater than or equal to is a closed circle. Remember that, guys. All right, closed circle. So now if I go back to this, I'm going to have J is less than or equal to 3. So which one am I going to use over here? Why is this not going up? I'll tell you something. I'm having a bad day with this. All right, less than or equal to 3. I'm going to use this one here. It's pointing to the left. So I'm going to hit that one. It's less than, everything is less than or equal to 3, and I drag it up to 3. That's it. All right, that's the answer right here. All right, let's move on to what number line? Well, just a 50%. Woo. All right, on this one, again, it's very similar to the one we did before. In this case, now it's greater than, so it's going to be an open circle. All right, so let's solve that one. All right, let's solve that one. So we have, m minus 7 is greater than negative 2 m plus 0.5. All right. So m minus 7 is greater than, distribute minus 2m, and distribute again. That just gives you what? Negative 2 times 0.5 is just negative 1. And let's solve for m now. I'm going to add 2m here plus 2m there. So that's going to give me 3m minus 7. Oops, minus 7 is greater than minus 1. And then I add 7 on both sides plus 7 on both sides. That gives me 3m is greater than, and did I make a mistake somewhere? I think it did. Minus 7, okay, minus 2m, plus 10, 1. Where did I make a mistake? I think I made a mistake somewhere. I add 2 on both sides. That gives me 3m there. And then do something wrong. I'm right. Okay, so then, so good. And then negative 1 plus 7 is somewhat I'm just tired. Okay, and so now I'm dividing both sides by 3, so that gives me m is greater than 2. See that? So this is going to be an open circle now, right? So because it's everything above 2, right? So therefore, I'm going to go with this one here. Let's go back to, right? So I'm going to use, and since we're talking about, I can't get to, oh, here we go. Right. And then everything up greater than 2, so everything's greater than 2. That's it right there. All right. I'll move on. Okay, here we go. What does it say here? The graph represents a quadratic function. Choose the correct answer. So, okay, and complete. So this is a choice. The function has a what? Maximum, minimum. Right? So this is a maximum, right? That's a maximum right there. And a value of, what's the maximum value? Well, you can see from the graph, the highest point of graph is at 4. That's 4 right there. And I cannot get to the other. Oh man, let me see if I go to 9 to what it's showing. That's it. Okay, I thought there was more to it. Okay, I thought there was more. I thought it was 4. All right, and that's it. All right, let's move on. Okay, on this one, it said a laboratory technician recorded population of species of bacteria each hour for 7 hours. Got it? Population in thousands after X hours can be multiplied by exponential function Good. Choose the correct answer. So the initial population, right? So you know, right? This is your initial value or your what? The 575, right? Is your initial value or your y-intercept. But it's the thousand, so it's gonna be has to be that one. The population is what? Is it increasing? Well, remember now, this is a very good one. Let's go back to the drawing table. Remember, oh, that's not it. Next one over. Remember, right? F of x is equal to 575. 1 plus point, that gives me 1.4. So bar x. All right, so this number is greater than 1. That means it's increasing. Right? That number is increasing. So let's go back to this one here. So it's increasing at a rate of what? 0.4 or 40%. Right? So be careful now, it's not 140. All right, the rate is R, which is 0.40, and as a decimal, as a percentage, is 40%. So you gotta be careful there. In fact, I need to stress this one. So remember, 1 plus 0.40, all right? 0.40 is R, that's the rate. So remember the formula, f of x is equal to a times 1 plus R, right? R is the rate. And here's the decimal, so it's 40%. Right. Just gotta be careful with that one. Let's go over to what else? Let's see. Right, that's it, right? Move on. Okay, I'm getting there. 15. Woo! All right, the graph of, you're given the graph showing which points are in the solution. All right. Now I gotta be careful now. Right. I want to make sure you first you have the right answers. Solve for y. All right. And I can tell it's going to be below the line because there are no negative numbers. Well, let's not say that. Solve for y, guys. Solve for y's. Solve for y. So we have. Let me go back to the drawing board. Again, whenever you have inequalities, solve for the y value. So we have 4x. We have 4x plus 5y is less than 20. In solve for y, minus 4x minus 4x, 5y is less than minus 4x plus 20. Divide by 5, that gives me 5 by 5. So y is less than negative 4 or 5x plus 4. So yes, so less than symbol. So everything below the line is less than, right? Everything below the line is what we're looking for. Is less than equals to less than. Okay. Go back to. All right. So everything less than below the line. So the only two is going to be below the line. Has to be that one and this one. It can't be the one next to the 4 and it's 5 because those are on the line. All right. So got to be careful with that. All right. Let's move on. Okay. This should be pretty easy, guys. What is the function? What are the zeros? Remember, zeros are x-intercept. They give you all these little circles on the graph for y'all. Zeros are x-intercept, so that one and that one. Pretty good. That's it. Easy points right there. Word number what? 17 in there. Okay, this one got to be tricky. I made a mistake on this one, and it's just bad habit with factoring. Let me go over here and see what I'm talking about. Okay. So we factor in this, right? You can graph this. If you're not sure to factor this, you can graph it and see what the factors are. Or you can use a box method. Now, you notice now we have 2x squared minus 14x plus 24. Okay. Now, if you notice the common factor between 2, 14, and 24 is 2. So I can write this as 2x squared minus 14 7x plus 12. Good. And so when you factor this down, you can use the box method. I'm not going to do the box method here, guys. That's the box method. You factor this in the box method, that's going to give you x minus 3 times x minus 4 times 2 right there. You got to bring on this 2. And those are the factors now. So therefore, when you do this now, you got to put this 2, you got to drag this 2 right there. 2. All right. Let's go back to. So now I know I'm going to have a 2. I think you're supposed to drag it. Positive 2. X minus 3, and the other one is x minus 4. That's it. Okay, let me see something. I'm going to put this on the, that's it. Again, just use the Xbox method and factor that. It's pretty easy to factor. All right, let's move on. What's my next step? What have we here? Okay. Again, this is a pretty easy one, but a lot of kids miss this one because they completely forgot about how to do this. Here we go. Again, they ask you what's the equation of the line. So remember, if you have a graph like this, if the line is parallel, right, and it goes to point 3, the equation is y is equal to 3. If you have an equation like this, and the line is vertical, and it goes through 4, because of course the x-axis is now x equals 4. Got a little difference, right? It crosses the y-axis, it could be y equals 3. It crosses the x-axis, it's x equals 4. Okay, so remember, you gotta be careful. So the answer is y equals, in this case, it's y equals 2, and the slope of a line like this is 0, m equals 0. Just gotta remember those 2 key things. Those are, let's go back here. So we have now, scroll down. So the line is y equals 2, and the slope, okay, drag it, okay. Can I go up further? I'm telling you, I'm on a bad day this morning. 80, still not, okay, and the slope now is m is 0, right? Okay, good. Next, is this a function or not? Remember, okay, and if you're not sure, this is a straight line, a linear line. It's going to look something like this. If you're not sure what the graph looks like, graph it. Come on. Okay, so this one, the first one, y equals negative 3.4x. You know it's going to be a line going to the origin like that. You know, a straight line. And every linear line is a function. Just remember that. That's a linear line, so yes, it's going to be a function. Now the second one, notice now the x value repeats itself. So that's not a function. And then this one, if I draw the vertical line test, yes, it only crossed the graph once, so that's a function. All right. So we go back here. Now we have, this is a function, all right, and not a function, this is a function. All right. All right, so that's number 19. Whoa, I'm getting close. Man, I feel good. Let me take a break for a second, guys. All right, guys. So here we go now. Number 20, a little bit tricky. We did this in class with regression, but not very in depth. Key to remember is this. Okay, let's look at the first one. It wants to know, is there a link between the speed of a car that decreases and arrival time of a car at its destination? Is there a link between the speed of the car, when the car decreases, the arrival time decreases, or it's later on? Yes, there's a link there, all right? And so yes, we say it's a causation. But remember now, on a start, it is causation is also association. So they both go hand in hand. So yes, there is a link. Someone said both. Just remember now, again, let me stress this. Causation, they're looking for a link, all right? When the speed of the car decreases, is there a link between that and the arrival time of the car later on? Yes, it's going to slow down as far as arrival time. So yes, so there's a link there, there's a cause and effect. So we say there's a causation there. But just remember, if there's causation, you're also going to have association, all right? And so we always put both there. Okay, next one, when the temperature increases, the set of snow cones increases. You would think that's a true statement, right? Is there a link between temperature increases and the set of snow cones? But we know when temperature increases, it gets warmer, spring and summer. That's a direct link. Temperature increases, you're in the spring and summer. So there's a direct link. But that doesn't mean that you're going to have the increase of, yes, you're going to have the increase of snow cones, but it's not a direct link to snow cones. The link is between temperature increases and the season, but not between temperature and snow cones. That's a hard one to comprehend. So for this one, right, it is not a causation, right? It is neither. And the last one, open temperature. Again, the last one and the first one is very similar. When the open temperature increases, the cool time increases for the casserole. There's a link there. You increase temperature, the cool time increases. You may burn the food, you may burn, but it's going to cook. So there's a direct link there. So some say, well, again, when there's causation, there's also association. Big close. And I'm going to put a link on this one. Okay, number 21 is what? Here, again, you got to recognize what you're dealing with, right? If you're not sure if it's linear, exponential, look at the reference chart, right? Exponent is 2, so that is a quadratic. Now remember, the domain for quadratic is always all real numbers, if there's no restriction. All real numbers. And again, if you're not sure what the range is, graph it and see what the graph looks like. Here, okay, the graph is going to open upwards, and so -8 is the lowest point of the graph, and so the range is greater than y. Again, if you're not sure, graph it and see what the graph looks like, and you can see that -8 is the lowest point of the graph, so the range is y is greater than -8. All right, and then I think on the last one, it's a good one. Let me go to the other slide. Here we go. All right, now that's this one. Again, this is transformation, and so you have, again, you got to look at it. You got to know what kind of function are you dealing with, right? Fx equals x or y equals x. That's linear. You're dealing with a linear graph. Y equals x, and so we have y equals x. That is the standard. That is the parent graph, and you got transformed to y is equal to 3 times. Right? It is now 3/4. All right. X plus 4. That is the transformation. All right. That's transformation. I'm going to simplify this a little bit. I can distribute this. Y, makes it a little bit easy to see. Y equals 3/4 times x, multiply that. And 3/4 times 4 is just 3. And so now you can see that it's going to ask you the graph. You can now you can graph. If you want to see again, play with a graph. If you look at this two now, ask you which one has a steeper slope. Well, we know then 3/4 less than 1. So this one one has a steeper slope, right? F, the first graph, has a steeper slope. So F is steeper than G. That's a true statement. All right. Because here the slope is a fraction of 0.75. And you can graph it and you can see that this one has a steeper slope. Okay. Next. So no, that's not it right there. Okay, to create G, all right, to create the transform G, F is translated 4 units to the left. Is that a true statement? X plus 4, remember? If it's a plus 4, that means the graph shifts to the left. All right. And then the graph G to left. Okay, so that's that one. That's correct. No, no, I'm sorry. This is correct, right? Yeah, F is translated for you to create G. Yes, I'm sorry. That's correct. That's correct. This is not correct. And the x-intercept of G is 4 units to the left. The x-intercept, you can graph, if you graph these now, you can see that the x-intercept of G is 4 to the left. Okay, let's graph it, all right? Let's see. Let's use, I'm gonna graph these two. Let's see what it looks like. Where is mine? Okay. So let's graph this one. Home, I did a new graph, new, no, graph. So we have y equals x. That's my parent graph. Y equals x. Right. Enter. Good. The next one is, the next graph is 3/4 x plus 3. So let's go back and grab that one now. Press the tab key. So, oh no, don't do that. Don't do that. I hate when it does that. Let me type still. Let's see if it works. So y is equal to 3 divided by 4 x plus 3. Let's see, when you grab something, it helps you out. You see that now? Okay. And so the x-intercept for the G function is to the left. 1, 2, 1, 2, oops, 1, 2, okay, 1, 2, 3, 4. So 4 units to the left. So what it asks for, let's go back and put that one in. The x in there. So the x-intercept of G is 4 units to the left of F. All right. Okay, so that was the first one. And then I think that was it, right? G's, yes. Okay, I think that's it, guys. All right, so that's a quick review there, guys. You can see some of the questions given, you're shaking on some things, you got to review. Again, I cannot cover everything. I cannot cover everything. We'll look at the videos and do the best. Make sure you study this weekend. Again, you can do as many of these questions as you want. Do as many as you want. You can go, I'm trying to say you can do the practice test over and over again until you feel comfortable with the material, all right? All right, good luck.